All right, we are in number 2. This is a good time also to really try some of this and then check with the video when you get stuck, or check answers. Maybe if you're not stuck, just to confirm they're right. So it says draw the figure at stage 5. Whenever it asks this, at this point, you can omit this if you want to. I don't know that it's necessary to draw stage 5. The main goal is we want to build the equation and know where this comes from. It gives me a hint on B. It says how many blocks are in stage 0. So we need to figure out stage 0. Well, in order to figure out stage 0, we also need to figure out the rate of change, or the first difference. Because if we can figure this out, then we can go back in time and figure out stage 0. So throughout this pattern, the thing that happens is every time I'm adding sort of these 3 arms, we're adding 3 blocks. Then we're adding 3 more blocks. Then we're adding 3 more blocks. And also that would mean then I need to have a number here that when I add 3, I get to 1. And the answer is -2. I'm not sure how to draw that. You could draw 2 shaded algebra tiles, but it really doesn't matter. There's -2 blocks, whatever it looks like, and that's going to be very important for me to build my equation. C actually says we're now going to write an equation that gives the number of blocks B for any stage and show how it relates to your geometric model, and we're going to simplify our equation. Okay, well, for C, we're actually going to do this 2 ways. We already have an equation if we look at what we got in the answers above. We have the equation B equals our rate of change, which is 3, times the stage number, plus stage 0, which is -2. So let's test this. If we were to take stage 3, it has 2, 4, 6, 7. 7 blocks. 3 times 3 is 9, minus 2 is 7. So it checks out. All right, so we actually already marked it up. But down here, let's see if we can find another way to get the same equation, maybe a different way. And that's what we did in the other example. So let's see if we can find, well, here, and here are 3 apiece and 2 apiece. All right, let's see if we can build this. So we've got 3 sets of, we need to relate these to the stage number, or independent variable. Each one of these is 1 less than the stage number, but then we're missing our middle block. All right, let's see, these should be equal. So here's my other version of this. And I can mark it here too if I want to. All right, so B equals 3s minus 3 plus 1, which is B equals 3s minus 2. So it checks out. All right, so we built it 2 ways. First way was probably the easiest. All right, next up, D. We're going to explain how each part is shown in the model. So the constant -2 is the number of blocks in stage 0. What was the other number in our formula? It was a 3. The coefficient 3 is the number of blocks added. Or our rate of change, our growth rate. Every time we add 3 blocks after a stage passes by. Again, if you feel like you got this, maybe skip ahead, do these, pause the video, and then check them with the video. E, use your equation to determine the number of blocks in stage 100. So our equation was 3 times the stage number minus 2, which means that we have 298 blocks. F. Now they're going to ask the backwards version. If we know that we have 58 blocks, what stage are we in? So we're going to add 2 to solve this. This is like a baby equation compared to the things that we were solving in Module 1. And this is stage 20. We're going to fill out our table. I'm going to add 0 up at the top, 0, -2. And then it was 1, 4, 7, 10, and 13. Each says we're going to show the rate of change or the first difference. Each time it's going up by, for X or S1, and for Y, three. All right, so our ROC is, or our CFD is, I'm going to even try to color code this, 3 over 1. All right, where do these numbers show up in the table? So the coefficient 3 is the constant first difference. Like I said before, maybe rather than use rate of change again, since we've already used that for the geometric pattern, we'll use a different vocab word that means the same thing. And the constant -2 is the point 0, -2 up at that top of that table. Wasn't actually there, but we included it.